Someday I should really create a bloopers reel. This is my third attempt on this video, so fingers crossed that this one goes well. So the purpose of this video is to cover measuring area and volume. Okay, so this is the second video in a series of 3 that I'm going to do on measurement conversions. The first video we talked specifically about length, but within that video we did kind of an introduction to how to convert within the English measurement system, how to convert within the metric measurement system, and then how to convert between the two systems. So remember, the metric system is pretty easy. You're just multiplying and dividing by powers of 10, which means you're really just moving your decimal to the left and to the right. Okay, when you're converting within the metric system or converting between the two systems, it's a little bit different. You have to use something called dimensional analysis. And remember, dimensional analysis is the process of converting from one unit of measure to another by multiplying by one or more unit fractions. Okay, and remember, unit fractions are fractions that have a value of 1, but the numerator and denominator are made up of 2 different units. The numerator and denominator represent the same amount, so it's the same length or whatever, but it's just measured in 2 different units, okay? So you're going to see a lot more of the dimensional analysis in this video, okay? But for this video, we're going to focus on measuring area and volume. So let's jump to the whiteboard, okay? So when measuring area and volume, now remember, I do have 2 ways to make videos. I have my laptop, which is what I'm, bless my heart. I have my laptop, which is what I'm currently using. And then I have my tablet. When I use my tablet, the videos are much better, but sometimes I have to convert or I have to switch between different screens, and that's a lot easier to do on my laptop. So the penmanship is going to be a little messier on the laptop, but I can easily convert or switch between different screens, whereas I can't really do that as easily on my tablet, but the tablet's prettier. So it's a toss-up either way, okay? So measuring area and volume. Let's talk about area first, okay? So area measures the surface of a figure or a piece of land. So you can see what I mean about the penmanship not being super great here, but hopefully when I talk you through this, you can at least tell what I'm saying. So when you're dealing with area, you're measuring the surface of a figure or a space, or you're measuring a piece of land, okay? So imagine a room, okay? When we're measuring the area of a room, we're looking at the floor. So how much space does the floor contain? So imagine we want to measure a room, a bedroom, a classroom, whatever. We generally would measure that in square feet. So imagine a square that measures a foot on all 4 sides. That would be a square foot. And basically what we want to know is how many of these square feet cover this 2-dimensional surface, okay? So 2-dimensional surfaces are measured using area, and we measure using square units, okay? So area is definitely measured using square units. So imagine feet. So if I was measuring the area of my office or a classroom, I would measure it in square feet. So you can do feet with like the little 2, or you could quite literally just write out square feet, either way. But just know when you measure a 2-dimensional space, your units are square units. So imagine an actual square that measures a foot on all sides. How many of those cover a surface, okay? For volume, volume measures, that's supposed to be measures, sorry. So volume measures the space contained in a 3-dimensional figure. Okay, so imagine you have like a shoebox, okay, and you want to know the space contained in a shoebox. And let's say we wanted to measure this in inches. Well, we can't measure it in just linear inches. We would never cover that space. We don't want to measure it in square inches because we would cover one surface, but we would never get the space that fills up that surface. So what we do instead is imagine a cube. So like a little cube that measures an inch on all sides, okay? That is what we would use to measure volume. So volume is measured in cubic units. So again, if you're trying to measure a shoebox, it's literally little cubes that are an inch on all sides. So we would measure it in cubic units. You have to have cubic units to measure volume. You have to have square units to measure surfaces. And then you just have regular linear units to measure just flat out length. Okay, so that's what's happening here. Be very cognizant of your units in this particular section. Okay, now one thing we can do when we're talking about land area is we can talk about something called population density. So population density refers to the number of people approximately per unit of measure. So if you were measuring an area in acres, you would want to know how many people per acre. If you're measuring in square miles, you would want to know how many people per square mile. So the way you measure population density is you take the population of a particular area, a city, a town, a country, a county, a state, whatever. You take the population in people and you divide it by the area in either square miles or acres or whatever. Okay, so let's take California, for instance. At some point in the past, the population of California was 39,144,818 people. Now, the area of California in square miles is 163,695 square miles. So you can write it square miles like that. You could do MI with the little exponent of 2. Either way, it's square miles. Okay, so this is your setup. As long as you show me your setup, you can jump to the calculator. So 39,144,818 people divided by 163,695. And we're going to get approximately 239, bless my heart. You're really going to appreciate the videos that I do on my tablet. They're better. 239 people per square mile. That's the other way to write square mile. Now, something you have to take into consideration. We know the population of California is not evenly distributed. For example, if you're in like Los Angeles, you're going to have a ton of people within the boundary set by Los Angeles versus some area on like the northern part of the state that's much less populated. Okay, so the assumption with population density is that assuming the people were evenly distributed throughout the state, we would have approximately 239 people per square mile. Now, if you go into Los Angeles, it's going to be way higher than that. There are way more than 239 people per square mile versus somewhere in Northern California where there are way fewer than 239 people per square mile. So again, the assumption with population density is that the people are evenly distributed. Okay. Let's look at another example. So one thing that we need to know how to do is to convert between area and acres and square miles. So for us here in the US, the two most common ways that we measure property are acres and square miles. So let's know how to convert between the two. So let's say the National Park Service administers approximately 84 million acres. But let's say we're interested in knowing what that is in square miles. Okay, now we're going to have to use dimensional analysis. We're going to need a unit fraction. So what we need to know is some conversion that'll take us between acres and miles. Okay, well, square miles. So let's see if we can find our conversion sheet. Now, for the conversion sheet, we use this first part on length for the first video. For the second video, we're focusing on area and volume. And what we want to look for is some conversion within the English system that'll convert acres and square miles. And here we have it. 1 square mile is 640 acres. So let's see how much the National Park Service administers in square miles. Okay. So remember from the previous video, we start with what we know. We have 84 million acres. Pretend those zeros are beautiful. We need to multiply by a unit fraction that relates acres to square miles. Okay. And from our conversion sheet, we know that 1 square mile is 640 acres. Okay. So make note of where I put acres. So in my first unit fraction, acres is in the numerator. In the second, or not in the first unit fraction, but in the first fraction, acres is in the numerator. In the second unit fraction, acres is in the denominator. And the reason for that is this. I need the acres to cancel. And in math, things cancel top to bottom. And that's going to leave me with square miles, my desired unit, in the numerator. Okay. So let's clean up a little bit. In the numerator, I get 84 million times 1. Bless it. This is getting worse and worse. I think it's because I've tried this video 3 times and my arm is tired. So we have 84 million square miles in the numerator. Good grief. I really am trying. And then in the denominator, we're going to get 1 times 640. As long as you show me this setup, I'm happy for you to do the division on your calculator. So 84 million divided by 640. And we get that the National Park Service administers 131,250 square miles. Okay. So 84 million acres is equivalent to 131,250 square miles. Okay. So know how to find a population density, know how in the English measurement system to convert between acres and then miles, square miles. Okay. Now, one other thing that we have is a hectare. This is like the metric version of an acre. Okay. It is abbreviated HA. Okay, so it's just another way to measure a piece of land. Okay, so let's say that there is a property in Northern California that is on the market for $415,000 for 1.8 acres. Okay, the first thing we want to do with this is convert the property to hectares. So we want to take 1.8 acres and convert it to hectares, which I'm assuming most of us haven't heard of a hectare. Don't worry about it. It's not something you're going to see a lot, but it is just another way to measure land. Okay. So let's go back to our conversion sheet and see if we can find a conversion relating acres and hectares. So if we go down here, we're going between English and metric. All right. So we have 1 acre is approximately 0.4 hectares. So remember that because we're going to need that for our unit fraction. Okay, so we start with what we know, 1.8 acres, and just write it as a fraction. It'd be cool if I could spell, huh? We're going to write it as a fraction by putting it over 1. And now we're going to multiply it by a unit fraction that relates acres in the denominator to hectares in the numerator. Now I want the acres. Since in the first fraction, it's in the numerator. In the unit fraction, I want acres to be in the denominator, so they'll cancel. And remember, 1 acre is approximately 0.4 hectares. Okay, so let's clean it up a little bit. Acres cancel, which is exactly what we want. Hectares are left in the numerator. Again, that's our desired unit. We clean it up a little bit. The numerator is 1.8 times 0.4 hectares. And the denominator, I'm just going to get 1 times 1 or 1. I don't really need that. It's not going to do anything for me. So now you can jump to your calculator, do your multiplication, and we get that this piece of property in Northern California is 0.72 hectares. Okay. There you have it. So that's how you convert between acres and hectares. Again, it's just dimensional analysis. It's just a unit fraction. Just make sure you have that conversion sheet handy. Okay, so we know that this 1.8 acres in Northern California is equivalent to 0.72 hectares. And what we want to do now is figure out the price per hectare. So we want price per hectare. So we take the price of this property, divide it by the amount of space in hectares, so 0.72 hectares. And as long as you show me this setup, you can do the division on your calculator. So 415,000 divided by 0.72. So if this were a full hectare of property, the price of the property would be 576,000. I'm going to round to the nearest dollar, 389. So this property per hectare would run you $576,389. Okay. So again, when measuring land, you can do a couple of things. You can find a population density. Within the English measurement system, you can convert between acres and square miles, or here's an example of converting between US and metric, and you're doing hectares and acres. Okay, that's it. So let's do a few more examples. Okay, now we're going to talk volume too. And remember, volume is the space contained by a figure. You'll also deal with liquid measurements here because we can use a certain amount of liquid to fill up a three-dimensional figure. Okay, so for the next example, let's say a pool has a volume of 10,000 cubic feet. Pretend that's beautiful. In fact, you know what? That's so ugly. I'm going to make it better. So we have a pool that has a volume of 10,000 cubic feet. We want to convert this to gallons, okay? So let's go over to the conversion sheet. Okay, so we've got the conversion sheet. Let's see what we can find. We want cubic feet to gallons. And if you look right here, we've got volume in cubic units right here. We have that 1 cubic foot is approximately 7.48 gallons. Okay, so remember 1 cubic foot, 7.48 gallons. All right, so we start with what we know. We know we have 10,000 cubic feet. I need to multiply that by a unit fraction that relates cubic feet to gallons. Okay. And 1 cubic foot is 7.48 gallons. So imagine a fish tank, will say, that measures, it's a cube and it measures a foot on all sides. It would hold 7.48 gallons of water. Okay. All right, so let's do the conversion here. We're going to clean things up a little bit. Let me go to blue ink. So the cubic feet cancel. Gallons are left over in the numerator. Okay, we're going to clean it up. For the numerator, we get 10,000 times 7.48 gallons. The denominator is really just 1, but if you have a denominator of 1, nothing really happens when you divide by 1, so we just leave it like this. So you can do this two ways. You could jump to a calculator and do 10,000 times 7.48, or you could understand how to multiply by powers of 10. I've got 1, 2, 3, 4 zeros in my power of 10. That tells me to move my decimal to the right 4 times. So I would get 74,800 gallons. And that would be our final answer. So if you have a 10,000 cubic foot swimming pool, it's going to hold 74,800 gallons of water. Okay, let's try another one. This time, let's say we have a fish pond and it holds 220,000 cubic centimeters. And we want to figure out how many liters of water are in this particular fish pond. So let's mosey on over to our formula sheet. All right, so we're looking for cubic centimeters to liters, okay? So we're going to go volume and capacity in the metric system and look right here. So specifically look right here. We have that 10,000 cubic centimeters is equal to 1 liter, okay? So remember, we're taking this fish pond, which is measured in cubic centimeters. We want to convert that to liters, okay? So 1,000 cubic centimeters is 1 liter. So we start with what we know. We have 220,000 cubic centimeters. I'm going to write it as a fraction. Then I'm going to multiply by a unit fraction that relates cubic centimeters and liters. Okay. And remember, 1 liter is equal to 1,000 cubic centimeters. Okay. So let's clean things up, figure this one out. So first we'll start with blue. Cubic centimeters cancel, leaving liters, which is my desired unit, in the numerator. Okay. There we go. So now for my numerator, I'm going to get 220,000 times 1 liters. In my denominator, I just get 1,000. Now you can go straight to your calculator and divide this out, or if you remember something about dividing by powers of 10, You just move your decimal 3 times. So we get that this particular fish pond holds 220 liters of water. And there you have it. Okay, so really most of what you're doing in this section is just dimensional analysis. You're converting from one unit to another. Okay, let's try another one. All right, in this case, a physician orders 20 cc's of an antibiotic to be administered every 12 hours. So first of all, cc's, what in the tarnation is a cc? Well, it stands for cubic centimeter, okay, or cubic centimeter. But as far as a liquid measurement, 1 cc equals 1 milliliter. And this is what you need to know. So for each cc, you're dealing with 1 milliliter. Now, this particular physician prescribed 20 cc's every 12 hours. Okay, so the first thing we want to know is how many milliliters should be administered. So 20 cc's, we need to first convert it to milliliters. And remember, I just told you that 1 cc is equal to 1 milliliter. So if I have 20 cc's, I have 20 milliliters. Okay, so that's the first thing you need to know. And then second, how many fluid ounces of the drug should be administered? So we have 20 milliliters, and we want to convert that to fluid ounces. FL period, OZ period is the abbreviation for fluid ounces. Okay, so let's go to our conversion sheet and see what we can find. So we're looking for a fluid ounce to milliliters, and we have it right here. So we're converting between English. English is fluid ounces, metric is milliliters, and we have that 1 fluid ounce is approximately 30 milliliters. Okay, so let's go back to the problem. We start with what we know. We have 20 milliliters. We're going to put that over 1, and then we're going to multiply by a unit fraction that relates milliliters and fluid ounces. Okay, so remember, 1 fluid ounce is approximately 30 milliliters. So we're going to clean this up and then work it out. Milliliters cancel, which is exactly what we want. We're left with fluid ounces, our desired unit, in the numerator. So the numerator is 20 times 1 fluid ounces. The denominator is 30. So you get 2/3 of a fluid ounce. Now, I like 2/3 of a fluid ounce, but directions could very well tell you to write your answer as a decimal. And if that's the case, work this out in your calculator. Let's say we round it to 2 decimal places. We would get 0.67 fluid ounces, approximately. Anytime you round, you got to use the little squiggly equal signs. So either of these would be fine. Okay, so the big thing here, the lesson to learn from this problem is 1 cc is 1 cubic centimeter. 1 cubic centimeter is equal to 1 milliliter. Okay, so in this section, there are going to be some of those problems again where you select the best estimate for the measure of something. We'll skip those for this video. And now let's look at some more examples. So let's say we have 8 cubic yards, and we want to convert this to gallons. Okay, so we need to go to the conversion sheet. We're looking for a conversion between cubic yards and gallons. So cubic yards and gallons right here. You do have to do a little digging, a little searching to find these sometimes, but 1 cubic yard is approximately 200 gallons. Okay, so let's go back to the whiteboard. All right, start with what we know. That's supposed to be a 3 right there. All right, now we're going to multiply by a unit fraction that relates cubic yards to gallons. And 1 cubic yard is approximately 200 gallons. Okay, so we clean things up a little bit. Cubic yards cancel. We're left with our desired unit gallons in the numerator. And the numerator is 8 times 200 gallons. The denominator is just 1, so we don't have to worry about that. And when we simplify this out, we get that 1,600 gallons would be needed for 8 cubic yards. And that's it. So really the heart and soul of this section is just dimensional analysis, converting from one unit to another. All right, let's look at another one. So let's say we have 45,000 cubic centimeters and we want to convert this to liters. Okay, so as always, let's go to the conversion sheet. So we're looking for cubic centimeters and liters. And I have right here, 1,000 cubic centimeters is equal to 1 liter. All right, so remember 1,000 cubic centimeters and 1 liter. We start with what we know, put it over 1, and then multiply by a unit fraction that relates cubic centimeters and liters. And remember, 1,000 cubic centimeters is equal to 1 liter. All right, we clean things up, figure out what we get. So cubic centimeters cancel, we're left with our desired unit liter in the numerator. For this example, my numerator is 45,000 times 1 liters. My denominator is just 1,000. So simplifying that either on paper or on the calculator, you get 45 liters. So if you have some kind of container that holds 45,000 cubic centimeters, it would also hold 45 liters of whatever fluid. All right, let's look at 2 more. All right, so let's say we have 80 milliliters to fluid ounces. So we've already done one like this, but nothing like a lot of practice to help you learn something. So we're looking for milliliters to fluid ounces, and we have it right here. So 1 fluid ounce is approximately 30 milliliters. So 1 fluid ounce is approximately 30 milliliters. So let's see, we have 80 milliliters. We'll just put that over 1. And I need to find a way to convert milliliters to fluid ounces. And remember, 1 milliliter or 1 fluid ounce is approximately 30 milliliters. So we're going to clean things up a little bit. Milliliters cancel. We're left with our desired unit in the numerator. My numerator simplified is going to be 80 times 1 fluid ounces all over 30. And you can simplify this however you like. If you use a calculator, you're going to get 2.67 fluid ounces, or you could get 2 2/3. So if you wanted to write this as a mixed number, it would be 2 2/3 fluid ounces. Just follow the directions. If they want the mixed number or if they want the decimal, go with the flow. Okay. But basically 80 milliliters is approximately 2.67 fluid ounces. Okay. Last one for this particular problem. Let's say we have 4.5 liters and we want to convert it to cubic centimeters. Okay. Now you might remember this one because we've done this one twice, but just in case, we need to know that there are 1,000 cubic centimeters in 1 liter. Okay, so 1,000 cubic centimeters per liter. So start with what you know. And multiply by a unit fraction that relates liters to cubic centimeters. All right, so remember 1 liter is 1,000 cubic centimeters. All right, and that just comes straight from the conversion sheet. Liters cancel, leaving our desired unit cubic centimeters in the numerator. Clean things up a little bit and we get 4.5 times 1,000 cubic centimeters. So 4.5 liters would be the same as 4,500 cubic centimeters. And that's it. So that's kind of the heart and soul of this section. It's really just dimensional analysis for almost everything. The only time we didn't really use dimensional analysis was right at the beginning of this. Remember population density, assuming the population of an area is evenly distributed, you take the population, divide it by the area of that region, and you can get your population density. We also looked at price per. So remember we had 1.8 acres, we converted it to hectares. We had a price, we wanted to know the price per hectare. So you just take price and divide it by area, and there you have it. Otherwise, everything else we did was basic dimensional analysis, okay? So make sure you understand how to convert from one unit to another using dimensional analysis, okay? So that's it for measuring area and volume. The last video in the series, we're gonna measure weight and temperature. All right, good luck.